Hey, my name is Patrick, and today we're going to talk about how to balance your steam heating system. So as always, we're going to start with basic theory and then kind of go to some specific examples. All right, so here we have our main, and we have, that is somewhere in the basement, let's call it, probably in the basement. And then we have two radiators, maybe in two different rooms, so that, yeah. And then, as always, the steam by now is filled, the boiler is working, it's producing steam, and then your main is filled with steam, and then that steam starts entering our radiators. Again, this all assuming that everything in your steam system is working correctly, your boiler is working correctly. Now, for the steam to enter the radiators, we need to have some kind of air vents. So add one air vent here and the same size air vent here. And then after X amount of time, whatever the time is, so the steam enters here, heats up this one radiator part, and then enters this way as well, and heats up this one radiator part. So obviously it's happening at the same time. Then another part as the air rushes out of the radiator via those vents. Another part as well. And then let's assume, for the sake of discussion, let's just one more. Let's add one more here and one more here. And now let's assume, for the sake of discussion, that our thermostat is somewhere here. And then that means that the thermostat detects the raise in the temperature in this specific room, because obviously this is our radiator that's giving off the steam, and shuts the boiler down. So now, as you notice, you have two radiators. One is almost filled with hotness, and the other one is quite empty, like 2/3, 1/3 of the way hot, and the 2/3 cold. So that means this room might feel nice and cozy, while this room might feel underpowered, or rather lukewarm. And especially that usually there are reasons why they put certain size radiators, certain spaces. Let's say this is more maybe larger room, or maybe with larger window openings and so on and so forth, while this is a smaller room and so on and so forth, and that's why. So how do we now solve our problem? That is, we have one properly heated room and one lukewarm room. Well, the way we solve it by varying the venting rates of our radiator. So in other words, when you have your air vents attached to your radiator, there's just a collection of different air vents. Is the air end is being pushed through this air vent again. So this is like an element. One of them is screwed to your radiator, at either this end or this end here, and then the air end is being pushed through it via this little opening, or this opening, or this opening. And then when the steam fills this vent, then there's an internal mechanism. Again, there's another video I made that you can learn more about it. Then the steam touches the element, and then the element closes the access to the air, and then the vent shuts down and encloses the steam inside the radiator. Again, this is for the purposes of illustration. So in essence, the steam will be hitting something. At least part of the steam will be hitting this vent for this to stop. So if we want this room, let's move those vents. If we wanted this room, or rather this radiator, to fill up to the same extent as this radiator, so that means, let's say, for the sake of discussion, almost the whole thing, so that the whole room can stay nice and warm, then we need to increase the venting rate of this radiator. How do we do it? Well, by increasing one of those openings here. If this, with the specific air vent, you basically remove this one and attach a bigger opening. This is one of the larger openings, actually, so we have a hard time doing this. But again, right now we're working with theory. Soon we're going to talk about the reality of how to accomplish it. Then with this one, you have this moving slot right here. So you basically, with this, if let's say right now this radiator is like this is closed, this is open, so you basically open up this slot so that more air could escape this radiator. Or you have one of those vents, then you have this dial at the bottom, so you basically unscrew it a little bit so that the more air can escape this radiator. So now I'm gonna do it with drawing. So let's say by increasing the air venting of this radiator by, let's say, by doubling it again with this is obviously relative sizes, then all of a sudden, if we are to redo the exact same scenario, so that means the boiler starts producing steam and the steam enters those radiators. Now this radiator has double the size of the venting. So after the X amount of time that we define, all those 6 ribs, so 3 ribs here and 6 ribs on this side, would heat up, and then start, as of course like this one, start giving off the heat to the room, and then hopefully that will be plenty for you to be cozy in this room where you set the thermostat, and then this room as well. So that's basically how you control the rate of heat distribution through your apartment or to your house, by controlling the sizes of those air vent openings. So on this sort of air vent, those openings come in different sizes. So this is actually kind of relatively large one. The radiators that are closest to the boiler, again, that's all theoretically speaking, because that's not always that simple. You would put relatively small openings, and then on the radiators far from the boiler, you put relatively large openings. And then at the same time, you have to consider that obviously a smaller radiator will overall heat up with the same size of opening, will heat up faster than a large radiator if the opening were to be the same one. How you cannot control it is that sometimes vents are like, let's say this one, this is like main vent, so obviously the large opening at the bottom shows you that this is main vent, but this company Gorton also makes radiator vents that kind of preset, they have preset openings, and you really can't control you can't control the venting rates, because then the opening is always preset, continuously preset. Incidentally, this kind of fascinating, great book, by the way, if you are into steam heat, talks about this, that if you have a oil burning or any sort of modern boiler that has either oil or gas, so that means it operates on and off principle, then that means you do have to kind of properly balance your system. You have to get adjustable air vents. You will never be able to do it with those that have preset opening. All right, so that's our theory. Now let's talk about the real world implication. So let me move this piece of paper and bring another piece of paper. So this is our imaginary house, where we have a boiler down here with some water in it. All right, and then we apply some heat to this boiler, and then in short amount of time the water turns into steam, and then that steam wants to travel somewhere. Now, so we have in the basement our main pipes. Again, this is schematics. Obviously, we're missing the return from the vent. We're missing header and a bunch of other things. This is to simplify things so that you can understand the theory. And then what we end up doing is we have, let's say, one air vent here, a large circle to imply that it's kind of a large opening to allow the main pipes to vent as quickly as possible, and another opening right here of the equal size. So let's see what happens after X amount of time. So the boiler starts producing the steam, and the moment a little bit of steam what's called materializes in the boiler, then it starts traveling, and it wants to travel with more or less the same speed, which is actually quite fast, to its larger openings. So obviously those two are large openings. So for the sake of discussion, after X amount of time, we have that much. Let's go all the way to this vent. Maybe this one will go all the way here. So as you can see, this is an equal distance because the venting rate on those two mains is the same. So because of that, it's equal distance from the boiler. So in other words, this if all things being equal, you're gonna have the same amount of steam in this main and then this main. And of course, when you have that steam, more steam gets produced, and all the other radiators start filling up. How fast those radiators start filling up is depending on the vent opening. So for the sake of discussion, as an experiment, let's give each of those radiators one small vent. As you can see, it's always the opposite of the inlet. One small vent, one small vent. So the steam in the main. So let's, for the sake of discussion, say that there's enough steam to fill that much of one part of the radiator. Yeah, this one as well, and here as well. Yeah. Now, let's say, for the sake of discussion, that let's fill up actually a little more. So actually, 2 parts of each radiator gets filled up. Let's say that our thermostat is near this radiator, somewhere in this room. So what ends up happening is this room right here gets the radiator gets nice and warm, and the thermostat is satisfied and turns off the call for heat, shutting down the boiler. So as you can see at this schematic, something happens. First, let's talk of all the things that happen. First of all, this boiler right here, and by the way, those numbers indicated in the number of each radiator, a number of sections is made from. So 4 section, which means those are the same radiators. 2 section, which means smaller radiator. 8 section means larger radiator, and 4 section. That means this radiator right here stays cold and will never get cold within our scenario. This radiator that, let's say, probably for some kind of purpose was somebody put such a large radiator in that specific room for whatever reason. Let's say it has big windows, big exposure to the cold weather of some sort. God knows what the reason is, but this radiator only stays lukewarm because only a quarter of this, the 2 sections out of 8, gets heated up. This radiator, only half of the radiator gets filled up, and this radiator, only half the radiator gets filled up. So let's say we have an issue. So how do we solve this issue? Once again, we start working with the size of the air vents openings, and then let's say if this small little vent with this low opening allows us to fill up 2 sections. So if you want all the 2 radiators to completely fill up, then we will have to increase this venting rate. So let's say double the dots. All right, there was some technical difficulties. So we're back. All right, so if you want, so now we know that the one little dot, the opening of this size, kind of here indicating with one little circle, can fill up 2 sections of the radiator. Then the same size radiator, the same size in terms of each section. If you want this for a radiator to fill up totally with steam, and this the same size as a radiator to fill up totally with steam, we need to double the venting of this one. So again, I added 2 dots, 2 circles here, 2 circles here, so that in our example it will fill up with the same amount of heat as this one. So again, starting from scratch, the boiler keeps on producing heat. The mains get the heat up. Then this radiator fills up with heat, and in the process, because those 2 air vents have much bigger openings, those 2 radiators fill up with heat at the exact same time as this one fills up with heat. So again, this one was called the thermostat gets satisfied because it's next to this radiator that before it turned the boiler off. The boiler is off again, and now we have one room that's nicely, with the whole radiator is nicely filled up with heat, and the room with the radiator is nicely filled up with heat, and the room with the thermostat is nicely filled up with heat as well. The problem is that those 2 spaces still remain very cold. So let's keep on experimenting. If we increase the venting rate with this radiator, and let's say for this one, let's go in this radiator as well. So we're increasing the venting rate to the exact same rate as this radiator and this radiator. So by the basic logic is that means that in the same amount of time, when the steam gets produced, then we get this radiator heating up fully, this radiator heating up fully because it doubled the venting to this radiator, this heating up fully because of double venting of this radiator, and this radiator heating up halfway across because it has the same venting rate as this one, and this one still staying cold even though you increase the venting. But the problem with that is that there's only so much steam that's being produced, and then so the steam still hasn't had time to vacate this whole space because of the limitations of your main air vents. For the sake of, before we solve the problem of this cold radiator, let's talk about this radiator. So what you might discover is that, let's say let's say you're using one of those vents and you open up all the way. So there's this double circles. It's really meaning opening up all the way, while this radiator is just on just halfway down. So that means to double the air venting rate of this radiator, with this one you have to open up all the way. And then when you open up totally, then that means you're kind of in a pickle, because that means that this radiator, at least in our practice here, will never heat up properly. What you can do is some people, well, there are two solutions. One solution is to decrease the venting rate of this radiator. So in other words, instead of having one circle, you give it half circle, if you can. So that means you would throttle it down so that even smaller amount of air comes out from this radiator. And that means if you give this radiator half circle, then those radiators will fill up totally, and those will fill up totally. And this one with half circle will heat up as well. Yeah. So that would be one solution. Another solution, if you, let's say, half circle is not the solution, so you keep one full circle as the size of the opening, and then you increase this venting rate of this radiator by adding another vent to this radiator. Just really quickly see if I can find the proper drawing to show you how this guy would do it. And there you go. So if you can see it, I pause it, and so here you have basically double tap where he's increasing the venting, doubling the venting rate, so that because of the size of this radiator. And there's another example, I think, where he's let's see if I can really quickly find it. Here in this example, he's tapping to a larger, so in other words, he's adding this main vent to the large radiator. If that's a possible another solution. And there's another yet solution. Let me just really quickly, there you go, something like this. So that means not only here you have double vents on this specific quotation mark oversized radiator, he's also adding another vent on the supply pipe to the radiator. So that's what's possible solutions for this oversized radiator. Another solution would be to maybe totally closed. Let's say if this room was somehow open to other parts of the house or the apartment, then you basically close down this valve right here, a supply valve, so that this radiator you can close it down totally, or you can close down the orifice. So you take a vent like this and screw it all the way in, so that nothing comes out through this opening anymore, and then that means this radiator would never heat up, and that means this thermostat could be satisfied only via warmth coming from other rooms. So that's a possible solution. But again, if you look at this schematic, we have this problematic radiator right here. The solution to this problem is to increase the venting rate of your main. So in other words, adding yet another vent right here. So let's see. Let's create a scenario, kind of somehow similar scenario, and see what happens. Let's see. So, to use our previous example, one main vent here, two main vents here, some water in the boiler, some heat for the boiler, and then steam gets produced via the boiler, and then the steam goes to this vent, and all the steam then goes to this vent. And when those main pipes are vented, then it's very easy to go for the radiators to get their steam based on their vents. So based on previous example, let's see, we're gonna have half circle. I'm gonna oversize those circles too, so you can see half circle here. We're gonna have let's say one circle here and one circle here, and then two circles here, and then let's say it's gonna give two circles here as well, because it's such the radiator is so far from the boiler. So let's see what happens when we do that. So because of half circle, so first after this first section heats up, then because the half circle here, we have two circles, so in the same amount of time as this one section heats up, two of those sections heat up, here and here. And then because we have two circles right here, so four of those sections heat up. Now, because of the size of the, as the boiler keeps on producing steam, what ends up happening is there's more and more steam in the system. So early on, when there's very little steam in the system, the steam slowly goes into its places, and then slowly goes here and here and so on. And finally, as more steam gets produced, it finally goes to the very end, and then finally this radiator gets it. So this two circles on this radiator doesn't necessarily mean that this radiator is gonna get as hot as this radiator, which means four sections. It could be that because of the distance from the boiler, it can only heat up, let's say, only two sections, even though it has two circles for the venting, just like this one. So just be aware of it. You know, again, all of its schematics, you know, you might ask, well, why is this radiator heating up so fast? And this radiator, if you kind of were going to on the schematic compare the distance, this is equal distance than this one. You're right, you know, maybe this radiator also requires two circles to warm up with the same speed. This is just kind of based on, you know, after we go through the theory, you discover that theory sometimes doesn't match reality, and then you have to play a bit more for this to kind of get it. But for the sake of discussion, let's assume this radiator needs the same venting as this radiator to have the two sections heated up. And then let's say if again we have the thermostat right here. The thermostat needs a bit more heat, so as the boiler keeps on producing steam, then we fill up this here more section, and again as before, that's one section with half circle equals two sections with full circles. So we have to get this. We notice that this is the same because of the double circles. Then this radiator heats up as well, and this radiator heats up as well. And before you know, you have nicely balanced system where all the radiators are making tons of warmth. Everyone is happy, including the thermostat, and the boiler shuts down, waiting for the call for the next call for heat from the thermostat. And that's how you balance the steam system in your house. All right, hopefully that was helpful.